Good evening to all present. So, starting with our session today, BioXSpace Synergizing STEM is at a mission to bring interdisciplinary learning at the central stage, where learners, high career seekers, researchers, and innovators are prepared for the opportunities that are provided in the 21st century. With this, beginning with our session, good evening to all. Dr. Das, thank you for joining us and giving us your time for this session.
Sure, Anandita. Thank you so much for the invitation, and it's my pleasure to be a part of this session.
So, before you begin, I'd like to give our audience a brief introduction about you. So, Dr. Das is currently pursuing her postdoc from University of California, Irvine. She received her PhD from Nanyang Technological University, Singapore, with a specialization in tissue engineering and regenerative medicine. She has completed her master's from IIT Delhi in May 2014 and a bachelor's from University of Calcutta in applied chemistry. Her research work is focused on the application of polymeric materials to fabricate biomedical devices. Overall, Dr. Das believes that repeatability and reproducibility are the major targets while fabricating medical devices, which may find a possible application in monitoring human diseases, analyzing disease mechanisms, and can act as a platform for high-throughput screening for potential therapeutic agents. In this regard, the analysis of statistical significance is an important approach to rely on methods, results, and ultimately the effectiveness of the final product. Overall, the path of analysis and studying its significance remains the same for documentation and acceptance of scientific findings. Thus, the current talk will be concentrating on the basic ideas of studying the significance of experimental data and the possible approaches. So, over to you, Dr. Das, now.
Thank you so much, Anandita. So, let's go to the presentation. Yes, so is it visible? Can you be able to see my slide?
Yes,
and then
yes,
yeah.
ma'am.
Oh, sure. Thank you so much. Okay. Okay, guys. So let's start the session. So today I'm going to talk about statistical analysis of experimental data. So this is a basic outline of the topics I'm going to discuss today. So first we're going to start with what is the need of the analysis of this data and why the repeatability and reproducibility of the data is so much important to claim some actual advancement in the science. Then we'll discuss about the type of approaches in statistics which actually can be applied to analyze the data. And we mainly talk about the probability value. We'll define it and we'll try to calculate it by different kind of approaches. So we already know that all over this research and development sector, people are running so many experiments. So what is the basic need for running this experiment? So they wanted to have some advancement in science. So after running the experiment, the first thing is that we get some data. So we acquired some data. Later on, we do some analysis of the data to have some observation about the data. So next thing is that we need to validate the data. How to validate the data? So for that, we need to see if the data is repeatable or not, and then if it is reproducible or not. So I'm talking about this repeatability and reproducibility from the beginning. So let's first talk about what this is actually are. So the repeatability is you wanted to quantify the change in the data when you are running the experiment in the identical circumstances by a same instrument or by a single person. So let's consider that in the lab you have a solution and you wanted to check the pH of the solution. And you also have a pH meter in the lab. So you check the pH of the solution and you found some data about the pH of your material. So now you wanted to know if the data you are getting is just by chance or it is actually a true value. So then you need to check the data again for the same solution, and if you are able to get the same data, that means that your experiment is repeatable, your data is repeatable, and if not, that means it is not repeatable. And what is reproducibility of the data? So reproducibility of the data is that like you need to run the whole experiment again and then need to check the pH of the same material by the same person or different person, and if like you are getting the same data, then it means that your data is reproducible, and if not, that means it is not reproduced. So how you're gonna quantitatively express this in a technical term? So when you're reporting the data, you need to portray it in a technical term. So here comes the role of the statistics. So statistics basically a mathematical tool for quantitatively analyze and represent your data, or I would say represent the trustworthiness of the data. So what are the major approaches for this data analysis? So data analysis could be a descriptive analysis or an inferential analysis. So the descriptive analysis is kind of gonna give you a summary of the data, like the mean, median, mode, etc. So let's consider that you have a fibrous sample, and in that fibrous sample, you took some images of the sample. Like here I am showing you a SEM image, the scanning electron microscopy images of a sample, and from there, I want to know what is the pore size distribution and as well as the pore size of this fibrous sample. So for that, I could have so many images, and from there actually I can able to calculate so many data points. But it is not very logical or practical to collect millions of data to confer like one single observation. So for that, what we gonna do, we are gonna like have a small sample, a representative sample from a total population, and from there first we are gonna run a descriptive analysis, and the descriptive analysis is gonna give you what is the count of the sample and also like the highest pore size, the mean, median, standard deviation, mode. So it is going to give you some observation of the data. It is kind of a summary of the data, but you cannot conclude anything from this descriptive analysis. So then we need to go for this inferential analysis. Like here, the name itself, like saying you wanted to infer something, you want to conclude something. So to conclude something, we need to run an inferential statistical analysis test. So this inferential statistical analysis test could be two types. Either it's a parametric test or a non-parametric test. Now, for the parametric and non-parametric test, we have some considerations, like which conditions can be applied when we are going for a parametric test and vice versa. So for the parametric test, the nature of the data have to be continuous. That means it is quantifiable data. Then the second is it have to be normally distributed. That means it is gonna fit in a bell curve. Then it should not have any kind of outliers. Outliers means what? Like you have a data set which mostly like 90 to 95% of the data is actually ranging between 40 to 100. But you got one data which is around like 500, 600. So this is an outlier. So this is not acceptable when you are running a parametric test. And the sample should be independent of each other. Like from the previous image, we got that 100 points. So we should take another image, and that two images are independent of each other. So this kind of situation we can have in case of the parametric test. Now, what is the condition for the non-parametric test? So for the non-parametric test, the data should be ordinal or nominal. So it is not continuous. It is not quantifiable as such. Then it have to be distribution free. You cannot put it in any kind of like distribution. And then you can consider much smaller sample size when you are running a non-parametric test compared to the parametric test. And when more in case of non-parametric test, the data is better represented by the median. Whereas in case of the parametric test, it is majorly represented by the mean of your data. So everything here we wanted to done. Why? Because we wanted to do we wanted to test that if the data is significant or not, if the data is actually resulting in some advancement in science or not. So before that, we should have some basic hypothesis. So the most basic hypothesis in your statistical analysis will be the null hypothesis. So the null hypothesis is saying that the possibility of occurrence of all the events are same or equal. So null hypothesis consider everything as same or equal. And any difference if you are getting from certain population, that could be just because by chance or by some experimental error. So, for example, we consider that the job availability before the pandemic is just equal to the job availability after the pandemic. This is my null hypothesis. And if this is not true, that is, if the job availability is higher or lower before and after pandemic, so in that case, we can say that the null hypothesis is neglected. It is not true. How we are going to say that? We need to calculate the p-value. So p-value is a tool by which we can validate the null hypothesis and we can say that if it is true or false. Now, let's talk about this p-value more. This is also called the probability value. It was introduced by R.A. Fisher in 1930. The value usually ranges between 0 to 1. So the 0 means that if you like, there is like 0% chance that your null hypothesis is true. And if you get a value of 1, and that means that it's like 100% chance the null hypothesis is true. Now, I have a simple example here. Let's consider a $1 coin and consider that it is a fair coin. That if you toss the coin, the possibility of occurrence of the head is 50% and same as for the tail occurrence as well. So if this is true, then your null hypothesis is true. And if this is not true, that means the alternate hypothesis is true. So this kind of test is also called the significance test. So the p-value, also known as the significance value. So now consider that you got a bell curve after conducting some experiment, and then here at some point you got like one point where you like saw that the p-value is 0.01. If the p-value is 0.01, in that case you can say that if you like run the experiment for 100 times, then you will get like come up with this point only once. And if the p-value is like 0.5, in that case, you can say that if you run the experiment for 100 times, then the possibility of like reaching to this point is like 50%. So like 50 times you're going to have this point in your experiment. So as I mentioned, the p-value is more closer to the 1. Then you can say that your null hypothesis is true and there is no significant difference between the groups. And if your null hypothesis is like not true, that means your p-value is very close to 0. And you can say that the difference between these different groups is very much significant. So it was also like mentioned by Fisher that if the p-value comes between 0.1 to 0.9, then you can completely trust the null hypothesis. Whereas if it is below 0.02, then you can strongly say that the null hypothesis is not true. However, there is some possibility of errors, and I will discuss it more in the readouts later. So before going further, I would like to emphasize on some other points. So the major point when you are doing any statistical analysis is sampling. So the sample you are using for doing any statistical analysis, it should be fair sample. That is, if you have if you're checking, for example, if you're checking the nutrition level in a certain population. So you cannot just consider only the nutrition level of the rich and neglecting the poor, or you cannot consider only the poor and neglecting the rich. So it should be a mixture of both of them, and it should be able to represent, the sample of yours should be able to represent the whole population. So that is also going to eliminate the bias of any kind of bias present in the sampling. And it is also depend on the nature of the sample. Like what you are actually wanted to confer from your data. So that also need to be considered when you are doing the sampling, and also the sample size depends on the same. And the other thing is that the sampling should be random. I mean, if you are doing like, if you're if you're like checking the nutrition level in a certain population, so it should be random enough to give you like a whole scenario of a certain population. However, it have to be systematic also. Systematic means you are checking the nutrition level of a certain population. However, there could be some people who migrate to that place and staying only for 1 and 2 years. So their nutrition level could be completely different from the nutrition level of the people who are born and brought up there. So again, your sampling also should be systematic. It should not be not considering any other point. So it should be very much focused. So another point is that when you are doing the sampling, you need to see that what kind of variables are present in the sample. So this is very important point, because on the basis of this types, you can actually decide you should go for a parametric test or for a non-parametric test. So usually the variables are two types. So one is this categorical variable, which is not possible to count, and another one is continuous variable, which can be counted. So now let's consider this situation where you have a polymer and you wanted to like modify the surface of the polymer, or chemically modify the polymer with different kind of proteins. So let's consider you have two different kind of proteins, and after this experiment you like calculate what is the amount of protein is actually got absorbed on the polymer surface. So here the number you are getting is called the continuous variable because it's quantifiable, and these are categorical variable. And the way you modify the polymer, there are two kind of protocols you use, and use it like randomly for both type of polymers. So these two are categorical variable and this is continuous variable. Again, consider another situation where you wanted to check if like the amount of protein you are adding to modify the polymer is actually affecting the final yield of the protein inside the polymer. So this is a table, is highly representative and used by statisticians to like study like which type of test they wanted to go for. So here it is saying categorical variable, continuous variable, and this is categorical variable, continuous variable. So if you have two or more continuous variable and you wanted to see the relationship between those continuous variables, like here you wanted to see the protein you applied to the protein absorbed in the polymer, is it like directly proportional, if there is any relationship present or not. So then you should go for a correlation study, also known as Pearson's correlation study. And there is another study which is called one sample t-test. So for the one sample t-test, when you only have like one continuous variable and you have a target value and you wanted to see that if your data is actually, the mean of your data is actually like complementing well to the target value or not. In that case, you will go for a one sample t-test. Now, if you have more than one sample, if you have two samples, and in the categorical variable, you should not have more than two types. In that case, you can go for a two sample t-test. And if you have more than two samples, then you should go for a ANOVA. And like if you wanted to see that if the categorical variables, like two different kind of categorical variable, they are affecting each other in any way. That means if the addition of collagen is something specific to protocol 1 or protocol 2, or addition of fibronectin is something specific to the protocol 1 or protocol 2, then you can check by using chi-square. And there is another thing called logical regression. So the logical regression you should use when you have a dependent categorical variable. So you wanted to see how your continuous variable is affecting the categorical variable. Like for example, you wanted to see a tumor, if it is malignant tumor or not. In that case, you have like different kind of imaging technique. You will go for different kind of imaging technique, and you will see that like from the image, the size of the tumor, and from there you want to conclude something on the situation of the tumor, if it is malignant or not. In that case, you should use this logical regression analysis. So later on, I'm gonna discuss some like some mostly like most commonly used this significance testing in my next slides. So this is called Pearson correlation test. So the one I discussed when you have like two continuous variable or more than two continuous variable, and you wanted to see the correlation between this like two kind of variables, then you are gonna use this Pearson correlation test. So the value usually ranges between -1 to +1. So it's more towards the minus side. That means that they are like more inversely correlated. That means if one increases, the another one decreases. And if it's more towards the plus side, then it means that they are like directly correlated. That means if one increases, then the next one will increase. So you can say like directly proportional situation or inversely proportional situation. Or there is a situation where there is no correlation. Then you will get a correlation coefficient 0. And that means that the two situations there is no correlation present between the two. So here is some examples. Like if you see that like age is increasing and also like salary is increasing with it. If it's like highly correlated, then it is like highly positive. Then if it's like mildly correlated, then you can say it's medium positive. Same as for this negative correlation study as well. If there is like vehicle speed, if the vehicle speed increases, that means the time of travel will reduce. So in that situation, you can say that there is a inverse correlation present between these two factors. And from there, you can say that they like from this graph, you can say that it is true, but there is present like less correlation. So you can say that small negative correlation. Or there is a situation where it could be like no correlation. That means even the fuel prices increases, there is no increase in flat trend occurs. But if someone wanted to like try to check the correlation by using Pearson correlation test, then they may end up with this kind of situation where they may not found any kind of correlation. So the next most used statistical test is the t-test. So the t-test is usually like two different types. One is this one sample t-test and another one is two sample t-test. So for the one sample t-test, when it is used, as I mentioned previously, that when you wanted to check the group of continuous variable with respect to a standard value, you wanted to compare that the data you are getting is actually complementing well, or like if it is like significantly different or equal to the standard value, then you run a one sample t-test. And if there is like more than one sample, then it will go for a two sample t-test. So for the two sample t-test, it could be like a paired sample t-test or it could be a independent sample t-test. So for the paired sample t-test, you will run a paired sample t-test when the groups are come from a single population. And if you go for a like independent sample t-test, then you can say that the groups are coming from two different populations. And another feature of this t-test is that it could be one-tailed t-test or two-tailed t-test. So if you have this bell curve and this endpoints, which may represent like 5% of the total population, so these are called the tail. Like 95% of your data is coming in this region, and only 5% are distributed within this tail region. So these are called tail. So you can run a one tail test when someone is like claiming that maybe someone is claiming that the nutrition level in this population is equal to some certain value, maybe X. So they are claiming that a certain value, it have to be equal to a certain value. In that case, you need to run a two-tailed test. A two-tailed test, that means that you are checking if the claimed value is actually real or not. Is the actual value is higher than the claimed value or lower than the claimed value? So the two-tailed test is actually run in both the directions. So you can say that. So two-tailed test used when someone is claiming that some data is equal to some certain data. So in that case, you can use two-tailed test to check if it's greater or lower than the claimed data. Whereas you can check the one-tailed test when someone is claiming that the data, like the nutrition level, is greater than some certain value or less than some certain value. The one-tailed test is actually run in one direction. That means it will only gonna check that if the data is actually less than the certain value or not, or greater than the certain value or not. So you can say that the thumb rule for the t-test is that, so you should not use the t-test when there is more than 2 samples. So t-test is only applicable when there is only 2 samples. So this is typical that a company reported that in certain protein bar, the amount of protein present is 25 grams. Now, how we are gonna validate this claim? So we have to get those protein bars and need to extract the protein and quantify it first, and then after we get some value, we want to run this one sample t-test according to this, like the claimed value, to check if it is true or not. So actually I have added the formulas, but no need to like remember this formulas at all. So I will add like the more description of like all of this text in the notes I'm gonna give after this session. And you actually can run the test in Excel or R to check the p-value and also do this test. Then the next is this independent 2-sample t-test. So for the independent 2-sample t-test, the thumb rule is that you should have like one continuous dependent variable and you should have one independent categorical variable. Now let's consider that in a company, we want to check if the male employees have equal height, or the average height of the male employees is equal to the average height of the female employees. So here the continuous dependent variable is the height of the employees. Whereas in case of this independent categorical variable, it is the type of the employee, that is male or female. So here we can directly use this independent 2-sample t-test. So here also I have put the formula. The next is the pair sample t-test. So for the pair sample t-test, here actually you wanted to have the t-test on the same group of people, or same group of population. Like you wanted to check, like you discovered some drug, like the new drug for the corona, and you wanted to see how it is gonna affect on a group of people. So for that, you will check it like before treatment and after treatment by measuring the body temperature of the people. So this is very like typical example. So same as previously here, the typical this formula for this one. However, no need to remember this one as well. Then the next very important this statistical analysis approach is the analysis of variance, also widely known as ANOVA. So for this one, the thumb rule is that we only gonna apply the ANOVA when you have like more than 2 samples. So when you have more than 2 samples, then you can apply ANOVA. Also, if you have like 2 categorical variable, 1 or 2 categorical variable, you can apply ANOVA. If you have more than 2 categorical variable, you can go for this Pearson's X-square test. Then the ANOVA cannot be used. So this is the one-way ANOVA. For the one-way ANOVA, you can use when you have only 1 categorical variable, and the two-way ANOVA you can use when you have like 2 categorical variables. So this is a typical example of the one-way ANOVA. So we can say that let's consider that you wanted to see if like for different type of fertilizer can increase or decrease the yield of a crop. So you wanted to compare maybe 3 different type of fertilizers. So you will have like 3 different plots, and from there you will finally get some yield of the crop, and for that one you can apply this one-way ANOVA. So the in this one, the independent categorical variable is the fertilizer, and you have this 3 different type of continuous variables. Now consider another situation when you have this two categorical variable, like you wanted to see how the changes in the fertilizer as well as the planting density can actually change the yield of your final product. So in that case you can use two-way ANOVA, because here you have like 2 different categorical variable. So like there's different techniques in this here. Like the most widely used technique, like I have also used so many times for like checking my data, the significance study. And when like you are actually presenting your paper or research paper, you need to add the p-value. You need to add the p-value for all your experiments. So here I like forgot to mention one thing. Usually the acceptance level for the p-value is 0.05. If it's like higher than 0.05, then you can consider that your null hypothesis is true. That means there is no significance, like no significant difference present at different kind of scenarios. Whereas if it is less than 0.05, then your null hypothesis is supposed to be false. Usually it is considered as false until unless you like consider like your tolerance level is lower than 0.05, that is your tolerance level is less than 5%. So in that case you can say that your like there is a significant difference present between like two different experiments or 2 different samples. So, like in summary, we can say that this validation of the data. So it's very important when we are actually claiming the advancement in science. And before data analysis, we have to understand that like what is the type of the data, what is the type of the variance actually present in the data. You can have your experimental design accordingly. So these things need to be like evaluated before you are doing any kind of data analysis. And the second is, depending on this factors, you can choose like which kind of tool should be correct for your data type, should be correct to analyze your data. And when you are getting to analyze the data, when you're doing the statistical analysis, this analysis can support your observations. You can say that your data is like significant or not. Okay. So let's have some questions then.
Thank you, Dr. Das, for giving such a wonderful session. I would request everybody from the audience to either type in their questions or ask them here if you have any. So Dr. Meena has a question. He's asking, what about the multivariate analysis?
Yeah, so for the multiple variables, like as I already mentioned, that it depends on type of variable. Like if you have like so many different type of continuous variable, you can surely go for a ANOVA. But if you have more than two categorical variable, then you can try some other test like Pearson's square test. So you can go for that kind of test. So
if anyone else has any question, you guys can please continue. If not, does anybody have any feedback or anything? So, ma'am, Dr. Meena is asking he needs more information on PCA.
Sure, sure. So actually, after the session, I'm gonna share like a written file and note, and I will include these points as well. So you can like go through that, and it's always welcome to get feedback on that as well. And you may get a better, like more information on this kind of like multivariate analysis in that.
So I guess that will be all for today. Thank you, Dr. Meena, for the questions, and
Sure.
thank you, Dr. Das, for giving us the time here at BioXSpace and explaining to us in every detail the statistical analysis. I learned a lot, and
Thank you.